We live on a water planet. It's everywhere. But have you ever stopped to think about the water in the glass on your table? That water might have once been part of a distant ocean or a storm cloud over a mountain. So how in the world did it get to you? Well, today we're going to follow that epic planet-sized journey that makes all life possible, the water cycle. Okay, so to really get why this cycle is so incredibly important, let's start with a mind-blowing fact. Get this. A whopping 97% of all the water on Earth is salt water. It's completely undrinkable for us and for pretty much all life on land. So, that brings up a pretty huge question, doesn't it? If almost all the water is salty, how does a planet that's just teeming with life get the constant supply of fresh water it desperately needs to survive? Well, the answer is this continuous, amazing journey. And to really understand it, really get it, we're going to follow the path of one single drop of water as it travels through this incredible global system. All right, our journey kicks off with the first big move, what I like to call the Great Ascent. This is the part where our little water droplet leaves the surface of the Earth and starts making its way up, up, up into the atmosphere. So our droplet can start this climb in one of two ways. The most common one is evaporation. That's when the sun's energy heats up oceans, lakes, and rivers, turning that liquid water into an invisible gas called water vapor. But it can also happen through something called transpiration, which is where plants basically breathe out water vapor from their leaves. And it's not a small amount. A single large oak tree can release 40,000 gallons of water into the air in just 1 year. Scientists have this fantastic word that smashes both of those processes together, evapotranspiration. So whether our droplet rises from the surface of a lake or gets released from the leaf of a giant redwood, it's all part of this massive upward flow of water into the air. But wait, there's a wild card here, a less common but super fascinating way to get into the atmosphere, sublimation. This is when solid ice or snow turns directly into water vapor, completely skipping the whole liquid phase. Just think of snow slowly vanishing from a mountaintop, even when it's way too cold to actually melt. That's sublimation in action. Okay, so our water droplet is now this tiny, invisible particle of vapor, just rising higher and higher. But you know what? It's not going to be alone for long. It's about to join a massive community up in the sky. And this community comes together through a process called condensation. See, as that warm, moist air rises, it starts to cool down, and that forces the water vapor to change back into tiny liquid droplets. These little droplets then cling to microscopic dust particles, and when billions and billions of them get together, well, they create the clouds we see floating in the sky. So there it is. Our droplet is now officially part of this huge, floating mass, just traveling along on air currents. But it can't stay up there forever, right? So the crucial question is, how does it complete the journey? How does it ever get back down to Earth? This next part, this is the climax of our droplet's journey. It's the moment it finally returns to the surface. Let's talk about the fallback to Earth. So inside that cloud, our droplet is constantly bumping into other droplets, and they merge and grow. It just keeps getting bigger and heavier until it reaches this tipping point where the air just can't hold it up anymore, and that's when gravity wins. The droplet begins its fall back to Earth as precipitation. And, depending on the temperature up in the clouds and on the way down, our droplet's big return can take a few different forms. It might fall as liquid rain, or, if it's cold enough, as delicate snowflakes, or icy sleet, or even as hard little pellets of hail. So our droplet has landed. Touchdown! But its journey is far from over. Nope. In fact, it's now facing a critical choice, a real fork in the road that's going to determine the next whole leg of its adventure. So the first path is what we call surface runoff. Here, our droplet just flows over the land, gathering in streams and rivers on a fast track right back to the ocean. The second path, though, is infiltration. This is where the droplet soaks down deep into the soil to become what we call groundwater. Think about that for a second. One route is this visible, fast-paced highway back to the sea, a journey that might take just days or weeks. But the other one, that's a slow, hidden journey. A water droplet that seeps into the ground might spend decades, maybe even centuries, or, believe it or not, millennia, in an underground aquifer before it ever sees the sun again. So we followed the pretty epic journey of a single drop, right? But now, let's zoom out, because when you multiply that one journey by trillions upon trillions of drops, you get a system that literally shapes our entire world. This global system does so much more than just move water around. It regulates our planet's temperature by distributing heat. It acts as the world's largest purification system, leaving all the impurities behind during evaporation. It's the absolute lifeblood that supports every single ecosystem, from the deepest forests to our own farms, providing the fresh water every living thing needs to survive. For thousands and thousands of years, this cycle has been this perfectly balanced system. But now, this incredible journey faces challenges it has never seen before. And that leaves us with the really critical question of our time. What happens when human activity starts to disrupt the epic journey of every single drop?